Welcome back, everyone. This P10 gas tungsten arc welding is the last module for the program. Page 3, how it works. Arc is struck by a non-consumable tungsten electrode. Tungsten is used because it has one of the highest melting temperatures. Welding techniques and fit up is very similar to oxy-fuel welding. The weld area is protected from atmosphere by an inert shielding gas, which is usually argon. For some joints, filler rods are not required. A joint done without the use of filler is called autogenous. You can use small tungstens at low heat, which helps to control distortion in light gauge materials. TIG welding, which means tungsten inert gas welding, can be used for joining or repairing most metals and most alloys. The main drawback is how clean the material must be and how slow it takes to deposit the material. A little bit of safety. Aluminum and stainless have highly reflective surfaces, so make sure to cover exposed skin, and darker clothing will reduce the reflection of light. Shielding gases are not toxic but can displace oxygen, especially in confined spaces. To promote proper breathing, areas must maintain a very minimum of 18% oxygen. But if it was me, I'd probably be concerned at 18% oxygen. High levels of ultraviolet light can cause oxygen molecules to form ozone. This is called allotropic transformation. Ozone is very toxic and can cause severe lung tissue damage. Here's a quick summary. Pause it if you need to. Power sources. Direct and constant currents are used. A constant current power supply is used. This is also referred to as a drooping voltage machine. Some additional features are high frequency, pulsing modes, pre and post purge, and slope in and out controls. Slope is referred to amperage up and down. Upslope initiates current at a lower amperage than the set welding current. This means when you strike the arc, amperage will be low, and then will start to heat up to whatever you set your machine to. So if you set your machine at 100, your slope is going to start at about 10 to 20 amps, and then once you start welding it, within 5 seconds it'll come up to that 100 amps you set it at. Moving on, welding currents used are direct current electrode negative and alternating current. DCEN is used for welding mild steel and stainless. This concentrates about 2/3 of the heat in the base metal, which allows for better arc control and gives deep penetration. Alternating current is used for welding aluminum and other non-ferrous alloys. The heat is distributed 50-50. There is a cleaning action in the electrode positive cycle that helps to lift the protective oxide layer in the weld zone of aluminum. Direct current electrode positive has shallower penetration in the base metal and 2/3 of the heat in the electrode. This is not used for TIG welding because the heat will consume the electrode and you won't be able to weld. The main thing direct current electrode positive is used for is for, very briefly, balling a tungsten for welding aluminum. AC power varies between direct current electrode negative and direct current electrode positive. Rectification is the conversion of AC to DC and results in a greater current flow in the electrode negative half cycle and a reduced electrode positive cycle. High frequency welding is a manufacturing process used for welding plastics together. The addition of high frequency to a welder helps to stabilize AC, and it also has a few other perks. High frequency is also used for a non-touch start, which helps to control tungsten contamination. As we talked about, it strengthens the electrode positive side of alternating current, and the high energy provides a charge or ionized gas path for welding current to make it stronger. Power sources must be grounded properly because high frequency can interfere with other high frequency machines and radio signals, which can damage the motherboard of a welder. Page 9, figure 8 shows a pulse current diagram. Pulse current gives better control over heat and was developed for welding thin materials out of position. Increasing and decreasing current as you start or finish a weld is called upslope and downslope. Upslope helps to control a start of a weld, and downslope helps to eliminate hot stops that result in fisheyes or craters when you finish your weld. Some torches operate at high currents and need to be water cooled. The water pressure is set at 35 to a maximum of 40 psi. Here's another summary. Figure 1, page 13. Diagram of type of current is on your test. Shielding gases, page 16. The shielding gases used for TIG welding are inert. They will not combine or interfere with the materials in the weld zone. The two most used gases are argon and helium. Argon is more widely used. It promotes a smooth, quiet arc with a strong cleaning action. It is 10 times heavier than helium and much better for drafty areas. For helium, you must run higher volts and amps, which gives you a hotter arc and more penetration. Helium is lighter than air, commonly used in balloons, as everybody knows. And for welding overhead, this may provide better gas coverage. Here we have the ionizing potential of argon at 16 volts and helium at 24 volts. This is the minimum required energy to get the benefits out of these gases. Leading and trailing gases prevent oxidation before and after the weld. Trailing cups are used for materials like titanium and tantalum. You can see this was a trailing cup here. These things are pretty expensive. It's often easier just to make your own. Page 19, regulators and flow meters are used to transfer gases to the weld area. Too much gas causes undercut and turbulence, which allows atmosphere into the weld area. When using a flow meter, the top of the ball gives the true measurement. Your flow rates for TIG welding are 15 to 25 cubic feet per hour. Here's another list of good things to know. Torches and components. Two basic types of torches is the water and air-cooled. Air-cooled torches limit out at around 150 amps. Water-cooled torches can carry upwards of 500 amps. The safe water pressure range is 35 to 40 psi. If you exceed this, you can probably get porosity from excessive cooling of the torch. The torch body holds all the guts, electricity, and shielding gas. The collet body transfers energy to the collet. The collet holds the electrode and gives it power. A gas lens, if available, prevents turbulence and improves weld quality. Here is a gas lens diagram. You can see without one of the gas lenses, gas scatters once it leaves the cup. Page 28, collet cap has an O-ring placed by the threads to prevent the loss of shielding gas. Gas nozzles direct shielding gas to the weld zone. Ceramic is most popular. Must be inspected for metal particles sticking on the inside of the cup. This causes atmospheric contamination and turbulence. Alumina is pretty strong, except in confined areas. It tends to overheat and break. Fused quartz are transparent, means you can see through them, and they give good visibility to the weld, and they're pretty cool. Here's a good picture of all the components of a basic setup. And here we have the last summary for this section. Take note of self-test 3, page 31, and the diagram, which will show up on your test. See you on the next one.